welcome. My name is Martin. I work as a developer at Cisco in the NSO core team. And today I'm going to talk a bit about what we have been doing in NSO with regards to high availability. So the changes we have made in NSO itself and the changes we have made to the high availability framework TAIL-F HCC, how this implies a new separation of concerns on who does what with regards to NSO high availability, and where we are going from here. So in order for this to make some sense, I'm going to provide some background, how it has worked up until now, and then move on to how it works in later versions of NSO and TAIL-F HCC. So up until NSO 5.3, including NSO 5.3, the high availability capabilities of NSO was rather limited. There were primitives for replicating the database between several nodes, and there was APIs for managing and creating a high availability framework to set statuses and roles. But there was no actual possibility of defining the different roles in NSO to set up this is the IP address of one node where the data is replicated, and defining which roles they should have and things like that. So for that to work, it has been required to use an external high availability framework. And the one we have provided to make this work is called TAIL-F HCC. And historically, TAIL-F HCC, up until version 4.5, has included a data model for defining the different members of the HA setup with IP address and an ID and things like that. There has been a number of actions for managing high availability, assigning roles or taking up and down the HA setup. There has been some failover logic, including in this package, not in NSO itself. And when it comes to routing traffic to NSO, there was solutions for both layer 2 and layer 3. For layer 2, virtual IP address solution that could move between different nodes, and a BGP Anycast solution for layer 3, primarily intended for geo-redundant setups. And this was based on an external BGP implementation called Quagga. But lately, we have been including some functionalities within NSO. And this comes as of NSO 5.4 and later. So what we have included here in NSO 5.4 and later is that the model for defining the different nodes in the HA setup is included out of the box in NSO, as well as a number of actions for running this. And for a standard high availability setup, no external package is needed at all. TAIL-F HCC still exists, and we will get to that in a minute or two. So we have aiming at making it more capable, but also simpler to reduce the number of moving parts in an NSO high availability setup. There has been a focus on improving feedback to the end user with the logging and error messages. It has been a bit difficult earlier to figure out what goes wrong if something goes wrong. There has been improvement done in how failover is handled and how you can configure it for your own liking. And the same for startup, how NSO should behave in regards to high availability when starting up the system has been improved, and there's more extensive configurability regarding this. So we have included the data model for high availability under high availability in root in the NSO system. And there are a number of new actions for enabling high availability and disabling it, and also temporarily assigning roles. As for configuration, you can define the different members of the HA setup with their IP addresses and their HA IDs. And you can assign default roles in the configuration. And there's various configuration settings for failover behavior and startup behavior. As of NSO 5.5, we have also included alarms, which was previously handled by the package and is now included in the system. So HA itself, how data is replicated and which node should have which HA role, and so that's now included in NSO itself. So the role provided by the package TLF HCC has changed a bit in version 5.0, which was released in June this year. And here I have the same tagline with fewer moving parts and simplified setup. We have unified the configuration for layer 2 and layer 3, so the configuration is way simplified, less reliefs to set. And we no longer manipulate the state of HA. We act primarily on notifications, and from the notifications regarding changes in HA state in NSO, we set we move a virtual IP address around, or we change the BGP settings to handle the BGP Anycast functionality. There's also a completely new BGP Anycast implementation, no longer based on Quagga, as that was not actively maintained. And with the new solution, we have removed the dependency on a NAD, so there's one less package to be installed for this. So the new BGP Anycast implementation in TLF HCC 5.0 is based on an interaction with a software called Go BGP. This software is not delivered by us, but it is freely available with a permissive license. And this interaction is now API driven. We don't go through a NAD, so that makes it easier to set this from a slave node, for example. And there's no need to have any more packages installed in NSO itself. In comparison to the earlier versions, the configuration of the BGP Anycast is simplified. We have suggested how to set it up with a default subset, which is what you can configure. It's a bit less flexible, but it's way easier to get it up and running. There's also improved user feedback that you can see the status of the BGP daemon in NSO itself, so there's less need to go to an external log to see the status or what's going on. And as mentioned earlier, you set the BGP Anycast or the VIP implementation in one place, and you just enable layer 2 or layer 3 functionality. And this is completely reactive. In previous version on TLF HCC, the logic for defining the behavior of the NSO HA setup was in the package itself. And now that is moved into NSO, while TLF HCC simply reacts to notification of HA state changes and affects this layer 2 or layer 3 settings. This makes for a more predictive and simpler solution, cleaner separation of concerns. But the old version of HCC still exists, and we have a new version. We also have a number of versions of NSO in deployment. So how do we work with this in practice? This is a bit of an exercise in combinatorics. As I've been mentioning so far, TLF HCC 5.x version 5 and later is intended for use with the built-in functionalities of NSO available in NSO 5.4 and later. There is no backwards compatibility at all in TLF HCC. So if you have a configuration in TLF HCC 4.x and want to move to the new solution, that will require a bit of work, not very much. There's not that much configuration to be set here, but you can't simply upgrade the package and have the configuration working. So for backwards compatibility reasons, we are still maintaining and releasing TLF HCC 4.x. So we are not forcing anyone into this new solution. If you just want to upgrade NSO and keep everything working as before, we are providing the means for this for now on. Probably not forever. And to avoid confusion, NSO built-in HA, all the new actions and the new configuration, this will be completely disabled if TLF HCC 4, version 4 something is installed. This is to avoid feature interaction between the logic in the old package, TLF HCC, and what we have built into NSO 5.0. It's also worth mentioning that even though TLF HCC 5.0 and the built-in functionalities of NSO works very well together and is designed together. They are independent. You can definitely use NSO without having tail-off HA at all. And if you would like to have your own logic or some external logic for managing failover and such things, you can still use tail-off HA to handle the virtual addresses and the BGP Anycast without even caring about the built-in HA in NSO, if that is what you want. And regarding future work, there's always more work to be done, and in this area is no exception. We are looking into primarily in the following areas. We are looking into improved observability of a NSO HA setup. So you can see the status of the various nodes in one single place in various ways. We are also looking into integration with external system. Say if you want to use, say, Raft or Paxos for a leader election, we are looking into how to easier make NSO built-in HA work with the external implementation of that rather than including it in the product itself. And we are looking into how to improve the sync times or minimize them, as we are aware that the sync times of NSO for large installation can be somewhat problematic, and that's an area that we are looking into. These are not committed features tied to any specific version of NSO that's upcoming, but these are our areas of interest with regards to high availability. And that was it for me.